Good afternoon, dear students. Audio video clear now? Please give reply. Very good. Now observe here. In this example, everything clear now? In this example, to find the node voltages, how many equations are required? To find the node voltages, how many equations are required? Please give reply. Yesterday discussed number of equations formula na? In this example, to find the node voltages, how many equations are required? Let's check it out. Now, according to our formula, yesterday we discussed number of equations equal to n minus 1. I hope all of you remember this one. In case of nodal analysis, total number of equations equal to n minus 1. Your meaning of n is total number of nodes, total number of principal nodes. Okay, this is the principal node 1, principal node 2, 3, 4. Total how many principal nodes are there? 4. 4 minus 1. Then total how many equations there? 3 equations. Total how many equations there? 3 equations. But in the questions, they may ask you to find out the node voltages in this network. Minimum how many equations are required? To find the node voltages in this network, minimum how many equations are required? Let us verify. In this example, let us assume node voltage of this one is a V1. The node voltage is a V2. Node voltage is a V3. Node voltage is a V4. Now, from the given information, what is the potential at this point? What is the ground potential equal to 0? Ground potential equal to 0. And the potential difference between V1 and ground, potential difference V1 and ground equal to Vs1. V1 equal to Vs1. Now, potential difference between V2 and ground equal to Vs2. Dekho ji, there is it possible to say V3 value directly? Is it possible to say V3 value directly? No. Reason is some resistance is present. In the same example, they may ask you to find out, to find the node voltages in this network, minimum how many equations are required? Minimum how many equations are required? In the given question, when the minimum word is present, then directly don't focus on this formula. Then focus on the actual KCL equations in the network. In this example, if there is a minimum number of equations, concentrate on the actual KCL equations. To find out the V1 value, have you developed any KCL equation? No. Directly got answer. To find the V2 value also, have you developed an KCL equation? No, directly got answer. But here to find out V3 here we have developed the KCL equation. By developing KCL equation only we can find out the node voltage 3. We can find out the V3 voltage, we can find out. That means in this particular example, minimum how many equations are required? Only one equation. Minimum how many equations are required? Only one equation. Write the note. एक note लिखो जी इधर. Draw this figure. Write the note. Very good. Very good. Very good. Don't worry, Sundana Kumari ji, Sundana ji, don't worry. Okay, write the note. In the above network, to find the node voltages, minimum one equation is required. To find the node voltages, minimum one equation is required. Underline that word minimum. In the brackets write KCL equations. KCL equations. एक क्वेश्चन लिखो जी इधर. क्वेश्चन लिखो. Find Vx of the network shown. Kushi Sharma, the previous one is the first slide, this is the second slide. Dhruv, we have to go for the mesh analysis. KVL equations बोलते mesh analysis. यार कुछ भी current source नहीं है ना Dhruv. That's why total number of equations equal to you get the total number of meshes. Okay, Dhruv. And one more thing, dear students, today I will take class only up to 3 o'clock. Again, our class will be continued on Monday. And Saturday, Sunday, you are having some other subjects. Okay. Prashant, if you want to write the KCL, we need a current of each branch. ये ब्रांच का करंट कितना है प्रशांत? V1 माइनस V2 बाई R1. ये करंट कितना है जी? V1 माइनस V3 बाई R4. मगर ये ब्रांच का करंट नहीं पता है आपको. केसीएल के लिए क्या चाहिए? करंट ऑफ द ईच ब्रांच इज रिक्वायर्ड. इधर कुछ भी करंट नहीं पता है आपको. दैट्स वाई डायरेक्टली वी कैन नॉट राइट द केसीएल इक्वेशन. मगर V1 वैल्यू डायरेक्टली बोल सकते हैं आप. कैसे बोल सकते हैं जी? विद V1 एंड ग्राउंड पोटेंशियल डिफरेंस कितना है जी? Vs1. दैट्स वाई V1 इक्वल Vs1. ओके, डोंट वरी, धीरे धीरे प्रैक्टिस करने से आपको सब कुछ क्लियर होगा. In this example, let us assume node voltage of this one is a V1. Node voltage V1. What about this node voltage is a V2? Node voltage V3. What is ground potential equal to 0? इधर ऐसा बोल सकते हैं ना, पोटेंशियल डिफरेंस बिटवीन V2 एंड ग्राउंड. देखिए इधर पोटेंशियल डिफरेंस V2 एंड ग्राउंड इक्वल टू 4 वोल्ट्स. इधर क्या है इधर? पोटेंशियल डिफरेंस V2 एंड ग्राउंड इक्वल 4 वोल्ट्स. मगर V2 इज कनेक्टेड विच वन है? नेगेटिव टर्मिनल. मगर V2 किधर है जी? इट इज कनेक्टेड टू नेगेटिव टर्मिनल. ऐसे लिख सकते हैं ना, दिस V2 इज इक्वल टू -4. पोटेंशियल डिफरेंस बिटवीन V2 एंड ग्राउंड इज कितना है जी? 4. मगर V2 कनेक्ट विच वन है? नेगेटिव. देन व्हाट यू गेट? -4. देन हियर इन दिस एग्जांपल, with respect to ground potential, what is the polarity at this point is a plus. Here भी क्या है जी? with respect to ground potential, polarity at this point is a plus. एक बार पेपर टर्न करो जी. go to the first class notes. एक बार पेपर टर्न करो, चेक करो आप एक बार. when the current source voltage source both are in series, which one can be neglected? when the voltage source and current source both are in series, याद है आपको? इन द फर्स्ट क्लास वी डिस्कस्ड. when the voltage source and current source both are in series, equivalent value is the only current source. Equivalent value is the only current source. याद है आपको? Now from that logic, can you neglect this one? From that logic, can you neglect this one? When the current source, voltage source both are in series, the voltage source can be neglected. Now let us simplify. इधर देखो जी, इधर ऐसा लिख सकते हैं ना, voltage across this entire branch both are the same. क्यों बोलते हो? दोनों ब्रांचेस कैसे है इधर? पैरेलल. voltage across this entire branch both are the same. कैसे लिख सकते हैं इधर? V1 equal to Vx. Then can you write the KCL equation at this point? If I write the KCL equation at this point by KCL, चेक करो जी. What do you write this? Vx by 1. हमेशा नोड इक्वेशन लिखते समय एजम्पशन क्या है? नोड वोल्टेज इज ग्रेटर व्हेन कंपेयर टू ऑल अदर वोल्टेजेस. हमेशा नोड इक्वेशन लिखते समय assumption is a node voltage greater when compared to all other voltages. From that assumption we write the equations. Then what do you write? The Vx by 1. Again here plus similar properties subtraction. हमेशा assumption क्या है? node voltage greater when compared to all other voltages. From that assumption we have written the equation. here पे देखिए 2Vx is outgoing current. here पे देखिए now plus कैसे है जी? plus similar polarities subtraction कैसे लिख सकते हैं इधर? For this example we can write this में Vx minus V2 by रेजिस्टेंस वाले कितना है इधर? 2 ohms. देखिए इधर branch 1 is completed, branch 2 completed, branch 3 completed, 4 also completed. इधर देखिए can you equate this entire equation to 0? In this example you know the V2 value. V2 equal how much? Minus 4. V2 equal how much? Minus 4. Now can you substitute V2 equal minus 4? Can you substitute V2 equal minus 4? Substitute the V2 equal minus 4 by simplifying this one. By simplifying this one, can you find out Vx? Check करो जी, find out Vx value. संजीव नेग्लेक्ट क्यों कर रहे हैं, रीजन बता दिए. संजीव फर्स्ट ओपन द क्लास नोट्स, गो टू द करंट सोर्सेस टॉपिक, गो टू द करंट सोर्सेस टॉपिक. संजीव करंट सोर्सेस में आई डिस्कस्ड द 5 फिगर्स, एक बार चेक कर लो. गो टू द 5th फिगर. इन द 5th फिगर अबाउट दैट वन ऑलरेडी एक्सप्लेन्ड. आप रिविजन नहीं करे तो मैं क्या करूं जी, रिविजन करना है. आप एक बार क्लास नोट्स ओपन कर लो. संजीव चेक करो, मिल गया आपको. गो टू द करंट सोर्सेस टॉपिक, फर्स्ट क्लास में डिस्कस किया. मैंने डिस्कस अबाउट करंट सोर्सेस, आइडियल करंट सोर्सेस, प्रैक्टिकल करंट सोर्सेस. बाद में डिस्कस अबाउट इक्विवेलेंट सर्किट्स. गो टू द फिगर 5. आई हैव टेकन एग्जांपल आल्सो. रिविजन करना है जी, रिविजन नहीं करे तो कैसे बोलिए. हाँ, find out Vx value. Yes, Vikas Kumar. With respect to ground, it is always positive. Check करो. Many students are saying 8/9. Check करो जी, is it correct? Many students are saying 8/9. We are writing a KCL at node 1 जी. क्या सुन रहे फिर? ऑलरेडी एक्सप्लेन ऑल द स्टेप्स. KCL किधर लगा रहे बोल के पूछ रहे आप. क्या नींद में है क्या? वेरी गुड. 8/9. Okay, write this question. Find Vs of the network shown. Find Vs of the network shown. देखिए, this is a Vs. Find Vs of the network shown. नो प्रॉब्लम. संजीव अब मिल गए ना आपको? संजीव रंजन क्लास नोट से मिल गए ना आपको? Harini, we are applying the KCL. Harini, in the question itself given, what you are saying? Current goes from higher potential to lower potential outgoing. It is also outgoing. एक क्वेश्चन दे दिया आप आउटगोइंग बोल के, फिर इनकमिंग कैसे लेते हैं? इट इज ऑलरेडी गिवन आउटगोइंग. करंट हमेशा एजम्पशन क्या है? करंट गोस फ्रॉम हायर पोटेंशियल टू लोअर पोटेंशियल, आउटगोइंग करंट्स. डायरेक्शन दे दिया जी, डायरेक्शन आउटगोइंग करंट दे दिया इधर. दिस फिगर. Arpit, with respect to ground, first we are saying the V2 is positive. With respect to ground, we are saying. Okay. Kushi Sharma, ground is a reference. Kushi Sharma, ground is a reference. From your doubts, I understand as a you need the more practice. And one more thing, dear students, in the first class itself, I gave that Alexander Sadiku book. Have you downloaded that one? All of you try to download that Alexander Sadiku book. From your doubts, I understand as a you need the more practice. शिवानी प्रैक्टिस, आप जितना प्रॉब्लम्स प्रैक्टिस करें तो उतना आइडियाज डेवलप होगा जी. ओके, नॉट विथ रेस्पेक्ट वीएक्स, ग्राउंड से ले रहे खुशी शर्मा. ओके, let us assume here the node voltage for this is V1, node voltage is V1. With respect to ground potential, the polarity of this one is a plus. Always the ground is a reference. With respect to ground potential, what is the polarity of this one is a plus. देखो जी, what is the outgoing current कितना है इधर? 3 is the incoming current at this point. कितना है जी? 3 is the incoming. Vx by 3 also incoming. क्या है? 3 is the incoming. Vx by 3 also incoming. टोटल करंट कितना है जी? 3 प्लस Vx by 3. समझ रहे ना? एट दिस पॉइंट 3 इज इनकमिंग, ए बी इनकमिंग. आउटगोइंग करंट कितना है इधर? 3 प्लस Vx by 3. वेयर एवर द करंट इज एंटरिंग दैट इज पॉजिटिव, अदर वन इज अ नेगेटिव. अदर वन इज अ नेगेटिव. वेयर एवर करंट इज एंटरिंग दैट इज पॉजिटिव, अदर वन इज अ नेगेटिव. देखिए, एंड कैन यू राइट द KCL इक्वेशन एट दिस नोड 1? In this example, can you write the KCL equation? Can you write the KCL equation at this node 1? If you write the KCL equation, कैसे लिखते हैं इधर? V1 by, हमेशा assumption क्या है? Current goes from the higher potential to lower potential. Current goes from the higher potential to lower potential. देखिए इधर V1 by, ये दोनों कैसा है जी? Series. 6 and 2 both are connected to the series. 6 and 2 both are connected to the series. करंट कैसे जाते हैं? हमेशा हाइयर पोटेंशियल टू लोअर पोटेंशियल. अगेन हियर वी राइट दिस V1 by 8. V1 by 8 आउटगोइंग. मगर इधर देखिए क्वेश्चन में दे दिया आपको, दिस एंटायर थिंग इज द इनकमिंग करंट. एंटायर थिंग इज द इनकमिंग करंट. 3 plus Vx by 3 incoming current. Sum of outgoing currents equal to sum of incoming currents. Sum of outgoing currents equal to sum of incoming currents. But in this equation, how many unknowns are there? 2 unknowns. One is the V1, other one is the Vx. Then can I select this here? In this example, voltage across this one, voltage across this entire branch, both are the same. For this example, voltage of this entire branch, voltage of the entire branch, both are the same. Can I select this here? The V1 voltage distributed between the first element and the second element. V1 voltage distributed between the first element and the second element. Now to relate these two, can you apply the voltage division technique? Can you apply the voltage division technique? Now for this entire branch, voltage how much here? V1. That V1 voltage distributed between the first element and the second element. Can I write this here? Vx equal to total voltage into similar resistance by total resistance. By total resistance. समझ रहे ना? Voltage अगर this entire branch कितना है जी? V1. V1 voltage distributed between the first element and the second element. Simply we are applying the voltage division technique. चेक करो जी, by solving this equation 1 and 2. चेक करो जी इधर, by solving this equation 1 and 2. Can you find out the V1 and Vx values? Do it. Substitute this equation 2. Substitute the equation 2 in equation 1. Simplify करके पहले V1 निकाल सकते ना? Find the V1 first, then have to find out the Vx value also. चेक करो जी, find out the V1 and Vx values. Jindal, in the weekends they are conducting other subjects, na? parallelly. I think weekends you are not free now. If you are free, I can take the class. In the weekends, Saturday, Sunday, you are occupied with other subjects ना. If other subjects are going on, how can I take the class? जिंदाल बोलिए. दत्ता जी आप क्वेश्चन पूछ रहे हैं अभी. ओके, फाइंड VS of the network shown. Find VS of the network shown. कितना है जी? V1 कितना है? Oh, so many answers. पहले इक्वेशन 2. Substitute this equation 2 in equation 1. इक्वेशन 2 को इक्वेशन 1 में पुट करो. पुट करके पहले V1 निकाल सकते ना. Many students are saying 18 and 4.5. And 4.5. ओके, वेरी गुड. Many students got the same answers. Okay. अब इधर देखियो जी. Now for this example, can you write the KVL equation for this one? For this entire loop. Can you write the KVL equation? देखिए, voltage across the 8 ohm resistor. How much here? V1. Voltage across the 8 ohm resistor, how much here? V1. Now can you write the respective KVL equation? Can you write the respective KVL equation? Now here the higher potential to lower potential voltage drop. Higher potential, lower potential voltage drop. ओके, इधर करंट कितना जा रहा है जी? रेजिस्टेंस 5. करंट कितना है? 3 + Vx/3. अगेन द हाइयर पोटेंशियल टू लोअर पोटेंशियल वोल्टेज ड्रॉप. अगेन हियर लोअर पोटेंशियल टू हाइयर पोटेंशियल वोल्टेज राइज. कैन यू इक्वेट दिस एंटायर एक्सप्रेशन टू 0? कैन यू इक्वेट दिस एंटायर एक्सप्रेशन 0? राइट द रेस्पेक्टिव केवीएल इक्वेशन. देखिए आपको इधर Vx वैल्यू पता है, V1 वैल्यू पता है, अननोन क्या है जी? Vs. सिंप्लीफाई करके Vs निकाल सकते हैं ना? चेक करो. मेनी स्टूडेंट्स आर सेइंग 40.5. चेक करो जी, इज इट करेक्ट? Can you please verify? Many students are saying 40.5. Is it correct? 40.5. Okay, very good. Ready this one. Find R1 and R2. Find R1 and R2 of the network shown. Find R1 and R2. Find R1 and R2 of the network shown. Now, Vaibhav, there you need the target is the VS now. We cannot neglect. नहीं करना है जी. दोनों करंट सोर्स है ना जी. VS is the voltage of the current source. VS is not voltage source. देखो इधर. Now for this example, let us assume node voltage of this one is V1, node voltage V1, node voltage V2, node voltage V3, node voltage V4. For this example, what is ground potential? For this example, what is the ground potential equal to 0? Ground potential equal to 0. Here the potential difference between V1 and ground. Potential difference V1 and ground equal to 100. Can you write this, sir? V1 equal to 100. Potential difference between V1 and ground. V1 and ground equal to 100. And what is V1 equal to 100? Potential difference between V3 and ground. V3 and ground is 40. Can you find the V3 value? V3 is 40. With respect to ground potential polarity क्या है इधर plus. हमेशा ground potential is taken as a reference. With respect to ground potential, again what is the polarity of this one is a plus. Now with respect to ground potential, again the polarity of this one is a plus. देखिए इधर for this example, can we select this here? The current always flows from the higher potential to lower potential. The current always flows from the higher potential to lower potential. The current of this one is I. Here the wherever the current is entering, there is a positive and other one is a negative. Can you apply the KCL at node 4? By KCL at node 4. If you apply KCL at node 4, in this example, can I select this here? I is the incoming current. I is the incoming current. What about this example? 5 is the outgoing. What is the 10 is also outgoing. 5 is outgoing, 10 is also outgoing. Incoming current should be equal to outgoing currents. I am writing the KCL equation at node 4. इधर simplify करने से कितना है जी? I equal how much? 15 amperes. कितना है जी? I equal 15 amperes. Here I equal 15. देखिए इधर रेजिस्टेंस वैल्यू कितना है इधर 2. रेजिस्टेंस कितना है इधर 2. 15 into 2. What is the voltage value? How much? 30 volts. Voltage कितना है जी? 30 volts. And the potential difference between V2 and ground. Potential difference V2 and ground equal to 30 volts. Potential difference between V2 and ground is 30 volts. Can I say the V2 value directly? कितना है जी V2 value? How much? 30 volts. समझ रहे ना? We applied the KCL at node 4. Node 4 we applied KCL. Simply we separate the incoming and the outgoing currents. Thereafter, can you apply KCL at node 1? By KCL at node 1. Can you apply KCL at node 1? Node 1 देखो जी. In this example, what is the 10 amperes is the incoming current. Node 1 के लिए 10 amperes is incoming current. मगर इधर देखिए हमेशा इक्वेशन लिखते समय एजम्पशन क्या है जी, नोड वोल्टेज इज द ग्रेटर, जो नोड वोल्टेज है ना, नोड वोल्टेज ग्रेटर। आप इधर V1 ग्रेटर मान लिया तो कैसे लिखना है, इधर करंट गोस हाइयर पोटेंशियल टू लोअर पोटेंशियल। ऑलवेज एजम्पशन इज अ वेर एवर यू आर राइटिंग इक्वेशन, आप इधर नोड 1 में लिखते बोले तो नोड 1 वोल्टेज इज ग्रेटर, इन दैट विद दैट एजम्पशन राइट द इक्वेशंस। क्यों बोलते हो, डोंट गो फॉर सो मेनी प्रोसीजर्स, गो फॉर वन यूनिफॉर्म प्रोसीजर। इधर नोडल एनालिसिस के डिफरेंट बुक्स दे फॉलो द डिफरेंट प्रोसीजर्स, कुछ भी फॉलो करने की जरूरत नहीं है, एक ही कॉमन प्रोसीजर। हमेशा टेक द नोड वोल्टेज ग्रेटर व्हेन कंपेयर टू ऑल अदर वोल्टेजेस, फ्रॉम दैट एजम्पशन राइट द इक्वेशंस। देखिए हियर द V1 इज द ग्रेटर, प्लस प्लस कैसे इज सिमिलर पोलैरिटी सब्ट्रैक्शन, V1 माइनस V2। इधर रेजिस्टेंस वाले कितना है, इधर 14, रेजिस्टेंस वाले कितना है, इधर 14 प्लस। अगेन इन दिस एग्जांपल प्लस 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 सिमिलर पोलैरिटी सब्ट्रैक्शन, V1 माइनस V3, V1 माइनस V3 बाई रेजिस्टेंस वाले कितना है, इधर R1, रेजिस्टेंस वाले R1। अब चेक करो जी, अब चेक करो, आपको V1 वैल्यू पता है, V2 पता है, V3 पता है। V1 V2 V3 वैल्यू सर नॉन, अननोन क्या है इधर R1। फॉर दिस एग्जांपल अननोन क्या है इधर R1। सिंप्लीफाई करो, सिंप्लीफाई करके R1 निकाल सकते हैं इधर, चेक करो जी, डू इट। डोंट वरी सूरज कुमार, धीरे धीरे प्रैक्टिस करने से सब कुछ आ जाएगा। धीरज कुमार, एवरी टाइम रिमेंबर वन पॉइंट, बाय सॉल्विंग ओनली 2-3 क्वेश्चंस डोंट थिंक एज ए यू विल बी एक्सेलेंट इन नेटवर्क्स, ऐसा मत समझो। पूरा प्रीवियस पेपर्स करने के बाद तब बोलना है स्टेटमेंट्स। जितना क्वेश्चंस प्रैक्टिस करें तो उतना धीरे धीरे आपका थॉट प्रोसेस डेवलप होगा। ओनली बाय सॉल्विंग 2-3 क्वेश्चंस बोले तो हो गया नोडल एनालिसिस, ऐसा मत समझो। आप ऐसा सोच रहा बोले तो you cannot get proper confidence on the subject। धीरे धीरे प्रैक्टिस करने से हो जाएगा ये। अभी फर्स्ट डे तो नहीं चल रहा ना आपको। ओके, R1 equal 12, R1 12, okay, very good, some students give R2 also, very good, I appreciate। Now can write the equation for node 3 by KCL, by KCL at node 3, by KCL at node 3। देखो जी, नोड 3 के लिए 5 इज द इनकमिंग करंट, नोड 3 के लिए 5 इज द इनकमिंग करंट, 5 इज द इनकमिंग करंट। इधर देखिए प्लस 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 सिमिलर पोलैरिटी सब्ट्रैक्शन, हमेशा एजम्पशन क्या है, नोड वोल्टेज ग्रेटर व्हेन कंपेयर टू ऑल अदर वोल्टेजेस। V3 माइनस V2 बाई रेजिस्टेंस कितना है इधर R2। इधर हमेशा एजम्पशन क्या है, नोड वोल्टेज इज ग्रेटर। Now current goes to the higher potential to lower potential, higher potential to lower potential, V3 minus V1, V3 minus V1 by what resistance is the R1, resistance is the R1। here आपको can you find out the, can you substitute respect to V1 V2 V3 values, can you substitute respect to V1 V2 V3 values। देखिए आपको R1 वैल्यू पता है, R1 वैल्यू पता है कितना है, R1 इक्वल हाउ मच 12। आप इधर सिंप्लीफाई करके R2 निकाल सकते हैं ना, सिंप्लीफाई करके R2 निकाल सकते हैं ना। Anu Kumari, what is your problem? Kumari जी, here I am getting so many messages, आपका प्रॉब्लम क्या है? Okay, one more, very good, very good, okay। Dear students, in the first class itself I conclude one point, in the first revision we'll do the so many mistakes. In the first revision it take a little more time also for solving the problems. Don't lose the confidence. It happened to each and every student. धीरे धीरे प्रैक्टिस करने से आप जितना प्रॉब्लम्स प्रैक्टिस करें तो धीरे धीरे आपको उतना क्लैरिटी आ जाएगा. ऐसा मत समझो कि नोडल एनालिसिस में मैं एक क्वेश्चन सॉल्व कर दिया पूरा नोडल एनालिसिस क्वेश्चन आना है, ऐसा मत समझिए. Do as many questions as possible, then you'll get more clarity. First priority is the class notes. First preference is class notes. Okay. Okay. Find I1, I2, I3 and I4 of the network shown. I1, I2, I3 and I4 of the network shown. आप थोड़ा सोचिए, then after I'll explain. सोचिए एक बार, how can you say answer? सोचो जी एक बार आप. Anu Kumari, at the end you can remind me. क्यों बोलते so many students are asking doubts ना. In that process I might have given reply to other students. Okay, Anu Kumari, at the end you can remind me. Don't worry. Okay, let's check it out. See, whenever any complex network is given, first think is there any way to simplify the network? For that one, first identify the connections. First to focus on the connections. Let us assume potential at this point is A, B, C, other one is D. Now for this example, first focus on this 25 ohms. This 25 ohms connected with the A to B. This 25 ohms connected. This 25 ohms connected with the A to B. Voltage across this one is a V1. Here the 25 ohms connected with the A to B. Now what about other one is the current source? The current source also connected with the A to B. Current source also connected A to B. Now current source कितना है जी? 0.2 V1. 0.2 V1. How the current is going from A to B? How the current is going from A to B? Now this A is connected together. And B is also connected together. This A is connected together, B is also connected together. Come to the 10 ohms. 10 ohms connected with the B and the C. 10 ohms connected with the B and the C. Now B is connected together. The C is connected. C is connected to the A. Come to the next one. Next, let us go to current source. Now correspond to this current source. 1.5 amperes. Current source connected with the C to D. Current source connected with the C to D. How the current is going from D to C? How the current is going from D to C? Now C is connected together. C is connected together. Now here the D is connected. D is connected to point B. This example, D is connected to the point B. Now come to last one. Last one is 100 ohms. Now for this 100 ohms here, one point is connected to the D. What about other one connected to the C? One is connected to the C. What about other one connected to the D? That means say given figure can you read it like this? To understand easy way, given figure can you read it like this? That means we can give statement as a all elements are connected together in the parallel. All the elements are in the parallel. Okay, धीरे practice करने से you'll get some idea about all these things. And one more thing, it is a conventional question. To get the idea about connections, I have taken some little lengthy question. It is a conventional question only. देखिए, now let us indicate I1, I2, I3, I4 positions. देखिए I1 position going from A to B. कौन सा resistance? 25. I1 current going from A to B in the 25 ohms. Come to I2. I2 current is going from B to D. कैसे जा रहे हैं? B to D. This I2 current is going from B to D. Come to I3. This I3 current is going from A to C. I3 current कैसे जा रहे हैं? A to C. A to C. देखिए I3 is going from A to C. Now this I4 is going from C to D in the 100 ohms. I4 current is going from C to D in the 100 ohms. Check करो जी. I indicate the respect to I1, I2, I3, I4 directions also. I indicate respect directions also. Okay. Always before solving the problem, focus on the connections. If you are able to identify connections, we can easily simplify the network. Somebody requested in the previous slide, Prashant. Copy कर लो जी. Are you asking this one? I think somebody asking this one. Copy कर लो. Okay. अब सॉल्व करेंगे. Now for this example, देखो जी, how the all elements are connected parallel. For this example, how the all elements are connected parallel. In this example, we already know voltage across this entire branch. Entire branch कितना है जी? V1. Same V1 is present. Same V1 is present for all the branches. Node voltage is V1. The same V1 is present for all the branches. Node voltage for V1. What about other end is a ground? Other end is a ground. This other end is a ground. What is our assumption? Current always flows from the higher potential to lower potential. What is the assumption? Current always flows from the higher potential to lower potential. Current always flows from the higher potential to lower potential. And एक statement याद रख लो इधर. Node equation लिखते समय take always assumption as node voltage greater. And don't focus on given I1, I2, I4 directions also. After finding node voltage, according to given current directions, conclude the answers. Always develop the uniform procedure while developing the node equation. While developing node equation, take the assumption node voltage greater. With that assumption, write the equation. After finding node voltages, according to given current directions, conclude the answers. Now, in this example, by KCL, here how to write the Voltage across all the branches are same. We write this V1 by 25. V1 by 25 outgoing current. And correspond this branch. What do you write? The V1 by 10 outgoing current. V1 by 10 outgoing current. What about the 2.5 also? Outgoing current. 2.5 outgoing current. What about this one? This V1 by 100. V1 by 100 also outgoing current. V1 by 100 also outgoing current. Then what about this one is a 0.2 V1. 0.2 V1 is the incoming current. 0.2 V1 is the incoming current. Now sum of outgoing currents equal to sum of incoming currents. Sum of outgoing currents equal to sum of incoming currents. By simplifying this one, can you find out respect to V1 value? Check it out. Check करो जी. Simplify करके V1 find out करो. शुभम शर्मा, हर एक एलिमेंट का ए बी पॉइंट चेक कर लो, किधर एलिमेंट कनेक्ट हुआ. मान लो देखो फर्स्ट एलिमेंट किधर है 25 ohms बिटवीन ए एंड बी. लाइक दिस वेरीफाई द सेकंड एलिमेंट, थर्ड एलिमेंट. हर एक एलिमेंट के लिए चेक करो पॉइंट्स, कौन सा पॉइंट्स के बीच में एलिमेंट कनेक्टेड हुआ, चेक कर लो. देन यू कैन आइडेंटिफाई कनेक्शंस. ओके, check करो जी. फाइंड आउट V1 वैल्यू. ओ जया, somebody give answers also. Very good, very good, very good, very good. हाँ बोलो जी, आंसर्स बोलिए. हाँ, somebody got V1. check करो. Many students are saying V1 is a 50 volts. Is it correct? check करो. Many students are saying V1 is a 50. ध्रुव, अब V1 फाइंड आउट करने के बाद अकॉर्डिंग टू गिवन डायरेक्शन I1 कंक्लूड करेंगे. आप टेंशन मत लो. नोड इक्वेशन लिखते समय हमेशा टेक नोड वोल्टेज ग्रेटर. 2 बार रिपीट कर दिया ध्रुव, फिर वही पूछ रहे हैं आप. ओके, हाँ. नो V1 कंप्लीटेड. अब क्या करेंगे? अकॉर्डिंग टू गिवन करंट डायरेक्शंस लेट अस कंक्लूड द आंसर्स. अकॉर्डिंग टू गिवन करंट डायरेक्शंस लेट अस कंक्लूड द आंसर्स. देखिए, in this example, what is the requirement? First requirement is the I1 value. To conclude the I1 value, what is the assumption? Current has to go from higher potential to lower potential. Current has to go from higher to lower. But how it is going? Lower to higher, lower to higher. Then what do you write this one? Minus V1 by 25. Minus V1 by 25. Getting ना? From given current direction only we are saying the answers. पहले नोड इक्वेशन लिखते समय assumption node voltage greater. V1 वाले कितना है? 50. Minus 50 by 25. Simplify करें तो कितना इधर? Minus 2 amperes. What is the answer? Minus 2 amperes. Okay. Now can read a KCL equation at this point. For this one, can read a KCL equation. Can read a KCL equation at this point. If you write the KCL equation, what about this? I1 is the outgoing current. I1 is outgoing current. What is the 0.2 V1 is also outgoing current. I1 outgoing, 0.2 V1 is outgoing. What is the I3 is also outgoing. Entire equation equated to 0. Entire equation equal to 0. I1 outgoing, I3 outgoing, 0.2 V1 also outgoing. Now for this example, you already know I1 value. I1 value how much? Minus 2. I1 equal to how much? Minus 2. What are the V1 equal to how much? 50. V1 equal to 50. I1 is known, V1 is known. From this one, can you find out the I3 value? From this one, can you find out respect to I3 value? Check करो जी. Find out the I3 value. Check करो. Somebody is saying I3 is minus 8. Is it correct? Others, anybody please reply. Check करो. Many students are saying I3 is a minus 8. minus 8 amperes. I1 current direction has to from B to A. B to कौन है नो? विकास कुमार थोड़ा ध्यान से देखो इधर. I1 current is a, देखिए इधर I1 current is going from the positive, again it is come back to the negative. That means it is entering at negative terminal. देखिए इधर डायरेक्शन ऐसा है, इधर डायरेक्शन थोड़ा ध्यान से देखिए विकास कुमार, ऐसा घूम रहे इधर. दैट मीन्स लिविंग फ्रॉम पॉजिटिव एंटरिंग एट नेगेटिव, एंटरिंग एट नेगेटिव. डायरेक्शन ध्यान से देखो जी. ओके ओके. नाउ नेक्स्ट लेट अस फाइंड आउट द I4. देखिए इधर फॉर I4 आल्सो करंट हैज टू गो फ्रॉम हायर पोटेंशियल टू लोअर पोटेंशियल. करंट हैज टू गो फ्रॉम हायर पोटेंशियल टू लोअर पोटेंशियल. बट हाउ इट इज गोइंग फ्रॉम लोअर पोटेंशियल टू हायर पोटेंशियल. But how it is going from lower potential to higher potential. हाँ, इधर I4 कंक्लूड करने के लिए, इधर I4 के लिए, then how to write equation? Current has to go from higher potential to lower potential. Minus V1 by 100. Minus V1 by 100. इधर V1 वैल्यू कितना है इधर 50. 50 by 100. Then what is the answer? Minus 1 by 2. Minus 1 by 2. Now can you apply KCL at this point? Can you apply KCL at this point? If you apply KCL at this point, what about the I2 is the incoming current? I2 is incoming current. What about this I4 is also incoming current? What about the 2.5 is outgoing? 2.5 is outgoing. I2 incoming, I4 incoming, 2.5 outgoing. Incoming currents equal to outgoing currents. Incoming currents equal to outgoing currents. इधर सिंप्लीफाई करके I2 निकाल सकते हैं इधर. चेक करो जी. आपको इधर I4 वैल्यू पता है कितना है जी? I4 इक्वल 0.5. I4 इक्वल 0.5. सिंप्लीफाई करके I2 निकालो. Check it out. What is the I2 value? How much? 3 amperes. Okay, very good, very good, very good, very good, very good. Okay. In the next class, I will discuss some more problems on the nodal analysis. All of you note on this link. It is a link correspond to Sadiku book. Link correspond to Sadiku book. In the first class, I gave the list of the books now. If you open this link, 2 files are there. One is a textbook. Other one is a solutions for the exercise problems. Check karo, 2 files are there. One is a textbook, other one is a solutions for all the exercise problems. All of you try to note down all these links in the first page. First page में आपका क्लास नोट्स में फर्स्ट पेज में नो कॉपी कर लो, या तो बाद में भूल जाते हैं आप. ओके. Those who are having the difficulty in the KVL, KCL, क्या करो? Go to the exercise problems. Go to the exercise problems correspond KVL, KCL chapter. Good number of questions are there. Question solutions are given clearly. क्यों बोलते हो? Without knowing KVL, KCL, we cannot do anything in the further chapters. First, revise our class notes. कुछ तो भी डिफिकल्ट लग रहा है और ज़्यादा प्रॉब्लम चाहिए to solve करने के लिए KVL KCL, then go for the exercise problems of this one. Try to download this one. Question solutions are given very clearly. Okay. And one more link I am providing. It is a link for workbook solutions. It is a link for complete workbook solutions. Note down carefully. These are the small letters, small u, small d. These are the capital letters, capital D, capital T, capital K. All of you try to download these workbook solutions, maintain this as reference. And remember, as the workbook solutions I am providing only for reference purpose. आप रिवीजन करते समय वर्कबुक अरे क्वेश्चन को आपका खुद का थॉट्स लगाना है, अप्लाई योर ओन थॉट्स, लेटर ओनली वेरीफाई योर सोल्यूशन. Don't see the solutions immediately. If you see a solution immediately, there is no use of this one. I am providing all these things only for reference purpose. And one more thing, in the workbook questions also, don't write anything in the workbook. Don't put any answers, don't write any hints also. होना बोल तो हर एक सेपरेट कॉपी में लिख लो वर्कबुक का जो सेपरेट क्वेश्चंस. रीजन क्या है बोल तो जब रीजन करते समय आप वर्कबुक ओपन करें तो ओनली यू हैव टू सी द क्वेश्चन, ओनली क्वेश्चन दिखना है आपको, नो आंसर नो हिंट्स. होना बोल तो पुट वन सेपरेट नोट्स फॉर वर्कबुक, ट्राई टू राइट द ऑल द सॉल्यूशंस. Okay, note on this link for this workbook solutions also. There is a zip file, Chandra Pal, that is a zip file. रायर फाइल ओपन करना है, लैपटॉप नहीं तो डेस्कटॉप में ट्राई कर लो. ओके, it is one more link. In this link I provide the homework problems. Here in the common link itself I give the homework problems to all the chapters. Homework problems correspond to nodal mesh analysis, steady state AC circuit, theorems, transients, two-port network. All the chapters का homework problems I give in the common link. Try to note on all these links in the first page of your class notes. Okay. With this one, today's class completed. Today I will take the class only up to 3 o'clock. Okay. Again, we have class on Monday. Evening you have class. Evening you are having some schedule, na? Then they will announce regarding Saturday schedules also. Evening they will announce. Okay. Okay, dear students. Your next class is at 6 p.m. You are 6 p.m. only. Your regular timings है ना evening batch का timings वही है. This is a 3U, not 34. 3U this one. 3 small u, small f, small r, small w. U this one, not 4. 3U. Oh, somebody asking Telegram ID कितना बार देना है जी? In the first class itself given a Telegram ID. The first class itself I gave my Telegram ID. It is my Telegram ID. Okay. It is underscore Kiran underscore networks underscore Kiran underscore networks underscore machines. In the evening they will announce 3 to 5 networks है वर्क नोट्स ओपन करके रिवाइज कर लो. अपना नेटवर्क्स क्लासेस ऑन मंडे इवनिंग यू हैव क्लासेस. दैट इवनिंग क्लास शेड्यूल इज देयर 6 to 10 and Saturday Sunday schedule they announce. See in the evening by they announce. Okay. अपना नेटवर्क्स क्लास नहीं है जी, नेटवर्क्स क्लास नहीं है. टुडे इवनिंग यू हैव क्लास. टुडे इवनिंग यू हैव क्लास. थोड़ा सुनो जी, आपका इसमें भी डाउट, शेड्यूल में भी डाउट पूछ रहे हैं आप. अपना नेटवर्क क्लास फिर मंडे है. इवनिंग यू हैव द रेगुलर क्लास. Saturday, Sunday also you are having some other subjects you are having. There is no holiday Saturday, Sunday. Okay. Okay, dear students.